So we've been graphing some really interesting shapes using polar equations. We can have rose-shaped graphs with different numbers of petals. We can have cardioids, spirals. But let's say that we want to show something like this pathway of the moon, and we really want to show our graph as it changes over time. So this is going to need a new kind of equations called parametric equations. Okay, so the way this works is we're going to introduce a new variable, and it's going to be the time variable. And so that's going to be our what we call our parameter, is our time. Okay, so I'm going to set this up. I'm given this equation. X equals t plus 1 and y equals t squared. Okay, so what you can do is just look at what happens over time. So we can just put in some time values like 0. Actually, we can even start back at -2, -1, 0, 1, and 2. And then we just go in there and play around and figure out, well, what would the x be at -t for t? So that would be -2 plus 1, just plugging that into our x. And so that would give us -1. And for our y, we would get -2 squared, which would be 4. Here we would get 0 for x when we plug in -1 for t, 1 for y, -1 squared is 1. Here we would get 1 if we plugged in 0 for t, and 0. And then we'd get 2 and 1, and let's see, t plus 1, so that would be 3, and t squared, that would be 4 for our y. Now what we'll do is just go through and graph these. So when t equals -2, we're at the point x is -1, y is 4. So this is at t equals -2. Now at t equals -1, we're at 0, 1. So our graph is going down. All right, at t0, we're at 1, 0. And then we go to 2 for x and 1 for y, and then that was at t equals 1. And then we go to 3 for x and 4 for y, and that was at t equals 2. And so what we get is this parabola moving from this point at -1t, and it's moving over through time, and then ends up back up at the point x equals 3, y equals 4. Now let me show you how we could rewrite this if we just wanted to know the equation without that parameter. We don't really care what's happening over time. We just want a sketch of what it looks like. So what we can do is just eliminate the t here. So I'm going to solve for t in one of the equations. Okay, then I'm going to take that expression and plug it into my other equation. So y equals t squared. Well, I'm going to replace t with my expression x minus 1. Okay, eliminate your t by getting t, solving for t in one equation, and then plugging your expression right in there into your other equation. So then you see, oh, yep, that's a parabola, and it's got its vertex at 0 and 1. Okay, so you choose your equation, solve for t, and then just plug that into your other equation, and then you'll have eliminated your parameter of t. All right, so we can go in and use GeoGebra and put our equation in. It automatically just goes from 0 to 2 pi, so if I want to show something different, we can just change that. For our t minimum and t maximum, we went up to 2, but it's okay to go up to 6. Okay, and now what we can do is animate this, and it will just show that parabola being drawn from left to right. Okay, let's try another one. So I have x equals 4 cosine t and y equals 4 cosine y. So I do know that x squared plus y squared equals r squared. And so let's see, the other thing I know is when we have y equals 4 sine t, that's going to be our r value. So we've got x squared plus y squared equals 16. So it's going to be a circle. It's going to be centered at 0, 0. And the radius is going to be 4. Okay, if that didn't quite make sense of, where that r came from and the r squared, you can also do substitution and plug r cosine t in for your x, and or 4 sine t in for your y, and just then factor out, square them, factor out your 16, and then use the Pythagorean identity. Cosine squared plus sine squared is equal to 1. All right, so that's good. We know it's going to be a circle. It has a radius of 4. So it's going to be looking like this, but what if we wanted to show that being drawn in real time? Okay, so we're going to use our parametric equations, and we're going to plug in t. We're going to calculate our x, calculate our y. Okay, I'm just going to plug some different t values in. I'm going to try 0. So that would be 4 cosine of 0. Well, cosine of 0 is 1, so 4 times 1 is 4. And then we would have 4 sine of 0. Well, sine of 0 is 0, so that would be the point at 4, 0. So that's at t equals 0. And let's try pi over 6. 4 times cosine of pi over 6, that would be 4 times square root of 3 over 2. So that would be 2 root 3. And here sine would be, sine of pi over 6 is 1/2, so 4 times 1/2 is 2. So x, 2 root 3, that's approximately, I just pulled out my calculator, that's approximately 3.5. Okay, so at 3.5, coming up, so that's at t equals pi over 6. And we just can keep plugging values in there. Let's see, I'm going to bump over to pi over 2. So we would have 4 times cosine of pi over 2. Well, cosine of pi over 2 is 0, so the x value would be 0. Sine of pi over 2, that's 1. So 4 times sine, that would be 4. So this is at t equals pi over 2. So this circle is being drawn as we go around and put in our t values. So with parametric equations, you want to show those arrows because it's really important to know the direction at which it's being drawn. Okay, most of you are pretty comfortable, hopefully, with Desmos, or feel at least like you can get to that site and use it. So GeoGebra is a little bit more complicated to set it up and work on it. It's, as you can see, if somebody else set up an application for you, it's it's kind of fun and you can play around with it. But let me just show you with Desmos. So what we do with Desmos is we actually enter a point. We're going to put it in as a coordinate, and so we're going to have a point here. So we need a parentheses. Now our x is defined as 4 cosine of t. And you have to find t. You got to just go into your into your alphabet there. Okay, and now we do comma, and the y is defined as 4 sine of t. Okay, so then we can end that up. And we can change our t values if we wanted to go from -2 to 2, or if we wanted to go from, let's say, -2 pi. And just type in pi and it'll, -2 pi. There we go. And that we got the whole thing starting at -2 to 2. But the only thing with Desmos is it goes so fast that you can't see the direction that your graph is going. And so you do need to get some key points, and just so you can at least figure out if it's being drawn from left to right or right to left. Okay, so those arrows are part of that graph. Okay, first we're going to eliminate the parameter, and then we'll graph and check with a graphing calculator. So usually our step is to solve for t in one equation, but neither of these would be that simple to do. If I solve for t, I would have arc cosine of y is equal to t, and then I'm going to try and plug that in here. That looks really hard. That's me being very scared. Okay, so let's see, x equals cosine of 2 theta. The thing that's coming to my mind is it's a double angle, and we have a formula for that. So let's just try it. Okay, let's see, x is, there's a bunch of cosine formulas. I'm going to try using this one where it is 2 times cosine t squared and then minus 1. All right, well, okay, let's see. We got rid of that. We decided not to try that, but we have an expression for cosine t. That's y. Oops, I erased my 1. Okay, so x equals 2 times cosine t quantity squared minus 1. Well, let's just replace cosine t with y. X equals 2 times y minus, or squared minus 1. So that is a parabola. Opens right with a vertex of 0, 1, 0, 1. Oh, negative 1, 0, negative 1. Okay. So, oops. All right. But I do want to just see a little tiny bit more here. Let's see what's going on. Where does it start? We know it goes, we know the vertex, we know it opens right. We could plug some x and y values into our rectangular equation and graph it, but I also want to know what's happening over time. So let me just plug a few numbers in. Let's do just 0, pi over 4, how about pi over 2, and pi. Okay, so x is cosine of 2 pi, or 2t, so cosine of 0, that is 1. Okay, good. And now our y is defined as cosine of t, so cosine of 0, that is 1. So there's our beginning point at t equals 0. And we could have started at t equals negative 2, or wherever we wanted, but we'll just get a sense of which direction it's going. So at pi over 4, we've got x is equal to cosine of 2 times pi over 4. That would be pi over 2. Okay, and the cosine of pi over 2 is 0, because that's the x value. Okay, and now for our y, we have cosine of just the angle, pi over 4. And that is square root of 2 over 2. And that's approximately 0.7. Okay, so this is drawing to the left. You could do a few more points in here. We'd get negative 1 and 0, and 1, negative 1. There we go. Okay, so we see the direction of our parabola. Okay, and so we can show this on GeoGebra. All right, so I just want to show this with Desmos as well, so we can go plug that in as an ordered pair, and then we'll type in for our parameter. Let's see, we could just have, these are kind of nice if you just put in your slider and then you go, there's our little parabola.